Alright, so in this video we're going to do the sample prep for DSC, or differential scanning calorimetry. So right here at the table I've got all the various tools I'm going to need. I've got some of our polymers that we're going to get down to size. I've got this device here, which is called a DSC crimper. It's so that we can attach a lid to our aluminum sample pans that are going to contain our polymer. And we've also got some various tools over here to get the samples down to size and transfer them from place to place. So there's going to be a couple different ways that we can do this, and it really depends on the thickness of the polymer. So this is sample 4 for this year, and it is relatively thin. So we're actually going to be able to basically use just the standard hole punch that you've used before, and maybe kindergarten or whatever various classes do, to make a little round, which is the perfect size for these aluminum sample pans, which I'll get you a closer view of in a second. If the material is too thick, so sample 3 is probably one of our thicker materials, so this one we probably won't be able to hole punch it, and so we'll have to basically get little pieces off with an X-Acto knife or a little sharp instrument. So those are going to be the two methods that we try. So when we come back here in a second, I'm going to set it up so that you can see the hole punching for the thin samples. Okay, so we've got sample number 4 here, and it's going to be kind of hard to visually see how thin it is, but the groups that have the sample can kind of attest to this. But this is a very thin sample, and so it's going to be very easy to punch with our hole punch. So we're using this because if we look at these sample pans, this is going to contain our sample. You'll see let me see if I can get a better view for you. It's very small. Whoop, just flew off. But you can see it's very small, and it's basically the same size as a punch that comes out of this hole punch. So I'm going to basically take our material and punch a couple holes and see if we can get one to go into the sample pan. All right, so here they're kind of staying on, so we can just kind of cut them off a little bit, but you see that we've made some punches with that. So I'll just use the X-Acto knife if we ever have to get them off the main material. And whenever you're using the X-Acto knife, you want to make sure that you're cutting on a good surface, so you don't want to scratch the table. All right, so I've got one, and just to be safe, I'll get another one cut out too. Make sure you're being safe whenever you use the X-Acto knife. Cut away from yourself, not towards your own hand or anything like that. So I'm just cutting away from my body. All right, so I've got a couple cut here that might be hard to see because they're on this piece of waypaper, but we've got them cut. And these sample boats, or sample pans, are made out of aluminum, and they're very small. As you can see, it's hard to get to image of. I'll try to get a picture for you to see there. And so if I just remove one of those, and also I need a lid, so these are just a simple piece of aluminum, and so I can grab one of these as well. And I'm using tweezers because everything's very small and difficult to reach, so I always have a set of these when we're dealing with DSC. And so what I'm going to do is basically lift up the little polymer sample you can see here, and I would just have to place it in there. And what we see is that even though the hole punch has punched it, it's a little bit bigger than the size of the pan, so that can happen if it's distorted a little bit. So we'll have to cut it down a little bit. So this happens, we're just trying to get it to the right size, and so that was a little too big. And so if I what I'm going to have to do is kind of go back to the piece of sample 4 that I've cut out, and it's sticking to my gloves a little bit, and that's pretty common, the sort of hydrostatic forces there. So I'll use the tweezers. And basically, if I just what I'm going to have to do is cut it down to size again with the X-Acto knife. So just try to cut off some of the edges so that it fits more nicely into the book. Alright, so I've cut some little pieces off. I'll try again, and sure enough, it fits in. So I've made it small enough now where that piece of the polymer will fit in. So that's the one approach. We can use a hole punch, and a lot of times it will work better if the material cuts clean. This one was stretching a little bit, and so that's why we had to use the X-Acto knife. So other polymers cut more cleanly, and then that piece will fit directly in. So I'm not to close this up yet. I'm gonna show you what it's gonna be like with the other materials here in a second. But this is if we have to use the hole punch. So we'll come back and I'll show you if we can't ever use the hole punch because the sample is thick. Okay, so now we're going to deal with the one that's a little thicker. So again, I don't know if you're able to see this, but this is polymer 3. It's quite a bit thicker, and so if I try to get the hole punch on it, it really won't do anything. You can see I'm putting a lot of force here and I can't even get it. You can see a little mark there up on the upper area here, but I couldn't cut anywhere near close to this. So now we're going to have to take a different approach. And so it's pretty simple, but it can be challenging to get small pieces. So what we're going to basically do is take these thick polymers and we're just going to go directly to the X-Acto knife because we want to get something small enough to go into these small aluminum boats or pans, as they're called. So basically what I'm going to do is I'm going to kind of attack a corner with the X-Acto knife, and not in a violent way, just get basically little shavings or small pieces that are going to fit in this aluminum boat. So I'll just kind of attack the corner with the X-Acto knife to try to get a few really small pieces. And so the approach here is I'm trying to get basically shaved pieces that are very small that I can add to the aluminum boat. And so you can get quite a few. We've got plenty of material, so I tend to just tell people to shave off quite a bit, and then we can just see how much we need to add to the boat, to the pan. Alright, so let me just show you what I've done here. So again, just shaving off the corner might be kind of difficult to see here. Yeah, so just these little flakes. So these are just really small pieces, and then I'll see what I can get to fit into the aluminum boat. So the same thing, we just kind of pick a couple up, see if you can get them to fit in the aluminum boat here. If they're too big, you can cut them down to size. If they're small, you can add more. It doesn't have to just be one piece. And so look, it looks like those go in quite well. So I've got a couple. The only other consideration we have to make is that the lid has to go on, and so you can't have a huge depth of sample in here. So and that will be more obvious when I show you this crimping device over here. So, so for right now I've got enough to put into the pan. And so we've got our sample ready to go. So either using the hole punch or the X-Acto knife or a combination of the two, we're good. We're ready to go to the next step. So now what we're going to do is, for the DSC, we want to make sure that we know how much material we're testing and how much of the polymer. And so what we're going to do now is we're going to transition over to the mass balance, and we're going to weigh the sample. We're also going to weigh the aluminum pan, and we do all this so that we know how much of the polymer we have in, but then we also know how much the aluminum pan weighs. And so that, in that case, we can also weigh the pan with the material after testing, and we can subtract the weight of the aluminum, and we can determine if there's been any changes to the mass of the polymer during the DSC run. And so that's why we always measure both the mass of the polymer and the mass of this aluminum pan. So I'll get that set up, and we'll come back and we'll look at the mass. All right, we're back here, and we're at the mass balance. You can see here, and we're going to weigh our polymer sample, and we're going to weigh the aluminum sample pan. So the first thing we want to do, as always with the balance, is that we want to put something down to weigh on. So I'm a fan of these weigh papers. So there's a box of them over here by the balance. So I'm going to place one on the scale so that we know that the surface is clean. And so once you've done that, you'll want to tare or tore the balance, and this should go to 0 if hopefully you can see that, or near 0. There might be a little variation there. One of the things you can check is to make sure all of the doors and the top is closed. We can try that again real quick. Okay, so we've got this. It's more or less 0. Again, there can be some variation there depending on how closed it is. So what we're going to do next is we want to weigh our sample. And so I'm going to open the door because I need to put the sample in. And one thing you might notice here, for the camera, I've done something I normally wouldn't do, is I put permanent marker on my little piece of polymer that I'm going to weigh, so that you can hopefully see it a little bit better. So that black piece, that black speck, that's what we're going to weigh. And so since we're dealing with such delicate small things, we're always going to use the tweezers. And so I'm going to place the piece on the weigh paper, and I'm going to close the door. And so we'll let it stabilize a little bit here. It's still going up. Now it's kind of stabilized a bit more, and you can see that the weight here is fluctuating at around 0.006 grams, which that means that is about 6 milligrams. And so we would definitely like to have at least 5 milligrams of the sample, and so this is a good weight to have. And so what we would do is we'd wait for this to fully stabilize, get our mass, and then take it off for the next. So I'm going to assume that we have the stable reading here, even though it's fluctuating a little bit. You also have to keep in mind that this is fluctuating at the 1/10 of a milligram, and so there can be a little bit more fluctuation there. So this might be as best we can get it. So we've got the mass of the polymer that we're going to add. So what I'll do is I'll go ahead and we can note that. We can take off the polymer, place it back out. We can make sure this is 0 again. If you're ever in doubt, you can always just tare again. And so at this point, we want to weigh the aluminum pan and its lid. So this is what, I know it's a little hard to see here, but this is the small aluminum pan and the lid for it that we're going to enclose our polymer in. And so if we ever want to get any measurements after the test, we need to be able to know how much mass this is. So I'm going to also weigh both of these parts as well. All right, and so you see again here, this time we're at about 26, 27 milligrams. So that's the mass of our aluminum pan and lid. They can fluctuate between the pans and lids that we have. So you always just want to make sure for the sample that you would be using, make sure you get a mass reading of the specific pan and lid that you're using so that you know how much is going in. So now I can add those together, and that's what's going in what will be the pan. And so if I ever have any doubts about what happened to it during DSC, if it lost mass or gained mass, I could take another reading after the test and subtract the mass of the aluminum pan. So that's what I'm going to do here. So this was for the small piece that we cut out with the hole punch. The principle would be the same with the other types where you're dealing with the small fragments. You'd want to weigh all the small fragments that are going to go into the boat, and then the same thing, weigh the aluminum pan as well. And so you'd want to record both of those readings in your lab notebook. All right, now we have everything masked that we're going to use. We're going to assemble the polymer into the pan, and then use this crimper to seal the lid to the pan so that it doesn't fall out and so that it's airtight. And so a lot of this you might not be able to see. This is the polymer that we just masked. It's again really hard to see, but the sample pan and lid are here. So basically what I'm going to do is, as you might imagine, I've got my polymer piece. I'm going to place it inside the pan. Using the tweezers, it's going to be a lot easier. Everything's very small, as you can see. And then the lid is just a flat piece of aluminum. And so I'm going to just place it on top, and it should go into the pan on top of the piece of polymer. And so if I kind of lift this up, hopefully you can see a little bit better that we have the pan, and then you see the reflective piece in the middle. That's the pan lid. And so there's still some extra aluminum on the side of the pan. And so basically what this device does is fold over, crimp the aluminum pan so that the lid cannot move. And so that makes everything sort of airtight and prevents anything from coming out or going in. And so we're basically going to... Alright, so I'm going to use the tweezers again and carry the aluminum pan with the lid in it and our polymer within. And if you couldn't see what I did, I pulled down this metal piece so that I could place the aluminum pan within this crimper. It's on a little stage. I'll see if I can move this a little closer so you can see. So the pan is just placed on there, and then this collar is basically going to move up. And so what's going to happen is I'm going to push this down, and it's going to move and go all the way down, and I'll push a little force, not too much. It says be gentle, don't hammer, so you don't want to slam down. You just need a little force. And then I'm going to pull this down again so I can remove my sample in the pan. And at this point, the lid should be crimped over the pan so that it's not going to come out. And so basically, at this point, this is ready to go. We have, we can put this in a vial so that we can transport it safely to the machine. But that is, if you can. Let me see if I can get a better view of it. That's ready to go. That's ready to go in the machine for our sample in the sample furnace side. So this is all ready to go, and that's all we use. So this is the nice thing about this machine, is it crimps the edges down for us so that we don't need to do it manually, because if you can actually do this, with a very delicate piece of with delicate tweezers, you can fold over the sides of the sample pan, but it's much easier if you can use this machine. So the procedure would be the same if we're using our little pieces of polymer. We would just place them into the sample pan and then look over and put this in the crimper to fold over that edge. All right, so one last note about the DSC sample prep. We've made our polymer samples in the pan, crimped them over, taken the mask before, all of that. And just one other note. So in the DSC, as you'll notice when you look at some of the schematics and so forth and the actual machine in the video, is there's two compartments or furnaces, and one of them is for our sample, but one of them is for a reference. And so it's important to know what's going into the reference. So the idea with the reference is that we're choosing a material that in the same temperature window, we don't get any thermal events from the reference material. So it's a very smooth curve. So if it underwent melting or crystallization or anything like that, then that would cause issues with the differential part of the differential scanning calorimetry. So we want something that doesn't do anything. And so for that, we just choose, again, one of these aluminum pans and a lid. So basically, instead of putting a polymer in it, we take a sample pan, we put the lid on, and we crimp it, and then we use that as our reference. So the reference is just a blank or empty aluminum pan with a lid on it. So you can assume a similar mass there, but no polymer. So that's our reference for these experiments.